Okay. Good afternoon, everyone. Welcome to the 148th talk hosted by Creative Weekend Talks. Creative is a group of people who are eager to gain new knowledge. Knowledge Square is our tagline. Sharing knowledge increases our knowledge. Today, we are thrilled to explore the fascinating intersection of space data and ICT development. Vision of Creative is to build a constructive thinking on various domains. We believe that by dwelling into the latest advancement and insight, we can inspire innovative idea and drive progress in our ever evolving world. We are honored to have distinguished expert joining us to share their knowledge and insight on how space data and ICT developments are shaped the future. This expertise will provide us with a deeper understanding of the technological advancement and potential applications that are evolutionize these fields. And I want to share this. We live streaming our program on YouTube channel, Creative GBD. Okay, and then I call Divya to introduce today's speaker. Over to Divya.
Thank you, ma'am. Good afternoon, one and all present here. I am Divya, volunteer of Creative. I am here to introduce our today's chief guest, PG Divakar, who is currently working as a ISRO Chair Professor, National Institute of Advanced Studies from IISc campus, Bangalore. He completed his PhD in Participatory Geomatics, NITK Surathkal, Karnataka. He specialized in space technology and applications, digital image processing and space data processing, application software design and development, geospatial technology and solutions. He worked majorly as a head in Regional Remote Sensing Center, Bangalore, and Associated Director, Earth Observatory System, ISRO headquarters in Bangalore, Program Director and Deputy Director, Scientific Secretary at ISRO, and Honorary Distinguished Professor in ISRO headquarters. He has 36 years of professional career at ISRO from Department of Space. He majorly worked in the fields of design and implementation of diverse space applications for several major national missions and space-based natural resources management for central and state ministries, web technologies, geo portals and mobile applications, international collaboration in space tech, innovative applications of space technologies, design, development and use of geospatial technology in addressing socio-economic issues. And his major international initiatives are Committee of Earth Observation Satellite, International Charter, Space and Major Disaster. He worked as a board member representing ISRO and country for more than a decade, involved in key decisions and also setting up a unique disaster data processing platform in ISRO to serve global community. And UN Economical and Social Commission for Asia and Pacific, Asia Pacific Regional Space Agency Forum. It took many new initiatives launched for ISRO to promote newer space applications in the forum, and he worked as lead ISRO in many bilateral coordination with key space agencies for cooperation in space sector and Earth observation related aspects. And his major awards are Globe Forum Award, Geospatial Excellence Award from Malaysia, and National Gold Award for innovative usage of technology and e-governance, National Geospatial Award from Indian Society of Geomatics, ISRO Team Excellence Award in 4 major national missions like agriculture, water resources, village development, Bhuvan Geo Portal. And he got ISRO Merit Award, ISRO Performance Excellence Award, and ISRO ASI Award, and Astronautical Society of India Award for development of Bhuvan Geo Portal. and he published more than 100 publications in national and international journals. And this is all about our today's chief guest. And I'm welcoming you, sir, for this session. And I'm welcoming all the participants of Reactive. I thank you, ma'am, for giving me this opportunity.
Thank you, Divya. And we encourage you to ask questions at the end of this session, so you can share your thoughts at the end. Okay, over to you, sir.
Yeah, good afternoon. Thank you very much for having me here as part of the creative talk. As was mentioned, I'm going to be addressing space data and information and communication technology for the development. This could be applicable not only to a country like India; it could be applicable to any other country in the world. I hope you are able to see the slides.
Yes, sir.
Okay. So what I'll do is I'll take you through a set of slides which will demonstrate the kind of capabilities what ISRO has been able to demonstrate in India. And many of these technologies have also been shared with many other countries, particularly developing countries in the neighborhood, so that the tools and technologies can be used by others also. India's focus has always been with respect to the use of space data for varieties of applications in the country, be it natural resources management, be it disaster management, be it ocean-related applications and varieties of other things. So space applications serve as the bedrock for all other developments, be it satellite fabrication or even launch vehicles. While doing the development of some of these applications, ISRO also has been working very closely with respect to institutional linkages so that various ministries, both at the center and state, are able to consume this data while we do a lot of advanced research with academia and work with the industry. Some of these activities have helped us in taking the space applications through to the ministries and hence helping the country in various developments. For doing these two things, of course, we have established a state-of-the-art ground segment in India where we are able to do varieties of space data acquisition and processing, the data product generation with the state-of-the-art tools and technologies. We have been able to establish in situ observation networks so that we are able to validate the kind of data what we get from space, and we have a very unique data and information dissemination mechanism. Of course, broadly, the space segment has addressed the water and land, the mapping, the ocean, the weather and climate. Typically, Earth is a moving object as we see from the rotation from west to east, while all our satellites, particularly the Earth resources satellites, move from pole to pole and they provide continuous information to the to our acquisition centers. We are able to acquire not only the data for India, but also have the coverage for the global. The idea of having this kind of an infrastructure is that we are able to address varieties of applications. In fact, there are hosts of satellites which ISRO has been able to develop and deploy, be it for natural resources mapping, be it for infrastructure development, be it for ocean, atmosphere and others. All these have been able to address wide varieties of developmental sectors. So the whole idea is to use the kind of data what we get from these satellites and ensure that varieties of areas of development takes place. The kind of technologies that have been developed while allowing the kind of satellites to be deployed up in space is something like the 3-tier imaging, very high resolution mapping, stereo imaging, which gives you the third dimension of the Earth, all weather imaging capabilities, ocean related applications, and varieties of other things. So the kind of sensors and the deployments that has taken place in space has addressed wide varieties of requirement on the ground. Typically, the example of an image that comes out from space can be seen here, where you are able to see very high resolution image fusion output, which gives you very accurate information about the features on the ground, while we are able to see natural resources information up in the right hand top corner, while below that we are able to see beautiful stereo images that provides the three-dimensional mapping of the Earth, which provides the vital information with respect to slopes and the gradients and other things. So such kind of data has been used for varieties of institutionalization, national level institutionalization projects. Like we have addressed agriculture, where we have a Ministry of Agriculture using the satellite data for predicting the yield and production much in advance with respect to the harvest of the crop itself. We have an excellent India Water Resources Information System. We have the forest sector being addressed by the Ministry of Environment, Forest and Climate Change. They basically look at the forest landscapes every 2 years. That means every 2 years we are able to get the status of forest in the country. While for the ocean, we have the Ministry of Earth Sciences addressing varieties of parameters using satellite data. It could be potential fishing zones, it could be ocean state forecast, tsunami advanced warning system, etc. On the other side, we have also been able to support the rural development and urban development related activities in the country through a very specific satellite data and information systems. And also the land resources, basically with respect to the national land use mapping, like what you see on the right hand side top. The entire country's land use land cover mapping we are able to do every year for the last 16 years, and this gives you an excellent time series of the kind of land use land cover mapping that is happening and how the landscapes are being utilized in the country, particularly from the food security angle. At the same time, the watershed development program has been utilizing the high resolution data for soil and water conservation, and disaster management is another major usage. In fact, these are the set of applications that has used the satellite data over a period of time, but time has come wherein we need to look at something beyond this. So while we are talking about the landscape mapping, that is the forest type mapping, we have also been able to address the biodiversity of the country. This is a very, very unique information system that has been developed, working very closely with the Department of Biotechnology, where we have been able to address more than 6,000 species database of 125 vegetation types. This has been done at various scales using 23 meter, 55 meter, and even today we are trying to use it even at 12.5 meter resolution satellite data, so that we are able to get the complete grip of the biodiversity in the country, particularly in terms of two parameters, that is biological richness and the biodiversity value. These two information give us the richness of the vegetation what we have in the Western Ghats, in the Himalayan range, as well as in the northeastern part of the country. Now, while the mapping has provided a lot of data and a lot of information to the country, it is necessary for us to look at various other things, particularly with respect to the geospatial technology and also linking the geospatial data with other data. For example, we would like to use the satellite images with the GIS platform while integrating that with the Internet of Things, the drones, and also the mobile applications, while GPS serves as the location-based system. While we are able to do this, it enables us to provide a lot of data that helps us to do much better analytics. So geospatial data analytics becomes a very crucial requirement for the country, because we are talking about the governance. Today we want to talk about governance using satellite data and other tools which we talk about with respect to the ICT technology. So there are varieties of new applications that are being developed, or we are trying to develop newer applications, which uses not only the data visualization, the quantitative measurements, but also uses the geospatial modeling techniques to enable such kind of activities using space data as well as ground data using varieties of sensors. Typically, when the country is looking at governance, particularly the e-governance, it is necessary for us to understand the basics of what we are talking about with respect to the governance. One part of it is the mapping, which India has pretty well established itself using space data. but the next goal is to see how well it helps the country in governance. Obviously, when we are looking at good governance, we are talking about accountability and transparency, equity, inclusiveness, effectiveness and efficiency, and also participatory. These are the typical parameters when we are looking at good governance. But when we are looking at e-governance, it is necessary that we have the right kind of technologies and also the policies and procedures in place so that we can serve the end users. When we do this, it is necessary that we enable the various social transformation. In fact, it results in social transformation. It plays a very catalytic role in economic development, leapfrog areas for development, as well as enhance the quality of life. We are using the space data with the varieties of geospatial technologies so that we are able to do online geoprocessing, use Boolean algebra for decision making, object tracking, particularly using the GPS-based techniques, use the machine learning and deep learning techniques for better learning algorithms, and obviously the modeling techniques from space. While we do this, we obviously need to be integrating the IoTs, drones, and cloud-based computing techniques. Some of the applications towards the governance we have already been able to establish with the government. Almost we are able to work with about 60 ministries in developing varieties of governance related applications. It could be soil health card, it could be the crop insurance, the irrigation potential of the soil with respect to the sustainable cities in the country, the Amrut program, and varieties of other things. While doing so, we have been able to bring in the use of the mobile tools. We are able to bring in the use of the varieties of other ICT technology, which helps us in ground-based computation as well as integrating that with the space-based data. I would like to possibly show you some typical examples of how well we are able to do this, and we are able to help the government already. This is one example where we are talking about soil and water conservation for the entire country. As you can see, we have pretty well spread across the entire country in addressing the application of technology for micro watershed development. The micro watershed basically addresses similar type of the terrain, particularly the terrain height, the gradient, and also it also understands, we also try to understand the soil content in this particular area, soil type in this particular area, so that we are able to utilize the space data with respect to terrain and soil and slopes and attribute that for the right kind of activities on the ground. This is typically the development of every watershed with respect to the soil and water conservation mechanism. We use mobile tools for ground-based data collection with attributes. At the same time, we use the space data for monitoring the kind of activities. For example, an afforestation takes place, before and after image very clearly shows what has happened, while on the ground implementation comes out through the mobile based tool. So we are using the GPS based mobile data as well as the space data for monitoring all the watershed development activities going on in the entire country. In fact, we are addressing about 86,000 watersheds that are being developed all across the country, which is a very unique thing for soil and water conservation. On the other end, we have interesting tools that are being used with respect to watershed development, wherein the new farm ponds coming up in a particular area, we are able to track it, or new type of vegetation that comes out over a period of time, we are able to track it from space data. The MGNREGA is another major program where we are looking at, it is in fact a flagship program of the country, which requires a lot of monitoring because huge amount of money is being spent on this. And here we are able to literally account for, in fact, we are able to create databases for more than 4 crore assets that has been created all across the country. So the money spending that happens from the government basically goes into varieties of activities on the ground with respect to the type of development that takes place for village development. While that happens, we are able to capture that from space data as well as from ground data through geotagging. And we do that in the prior condition, before the application is done, during and post active. So we are able to literally track all these happenings on the ground from space. So the public money that gets spent gets accounted for using space data as well as mobile based applications, so that we are able to track these as and when it happens. It's a typical e-governance based application that happens at the country level, where we are able to attribute the kind of public money spending that happens for development on the ground. This is another very unique example that helps us in understanding the energy situation in the country. This is the energy map of India, which we worked with Niti Aayog and the Power Ministry and various other stakeholders to see to that we have the power generation information that is available to the country, and we will be able to see the consumption versus demand. And when you are able to map that entire thing onto a WebGIS based technology, it is possible for us to bring that onto a interactive map. And this particular interactive map is able to tell you the total source of energy that is being developed. At the same time, if we are able to map the consumption levels, it is possible for you to see where are the gaps and how to address them. So a demand supply analysis is spatially possible today because of these kind of maps that has been produced. This is yet another unique application where we are able to track the important information with respect to the forest fires. We use 6 daily inputs that comes from different satellite images across the entire day, and we are able to process this particular data in near real time. We are able to provide information to the respective state department if there is a fire on the ground, based on the thermal data that we get from these satellites. And this entire data goes to that particular state within 30 minutes. That means after the satellite pass, within 30 minutes, we are able to provide this data in near real time, like what you see in this particular map of Uttarakhand, where we are able to provide this particular data on every fire occurrence, so that firefighting becomes much easier on the ground with such kind of near real time information coming in. This is again the utilization of satellite data for yet another important e-governance based application, where we are talking about House for All program, PM's Awas Yojana, where we have been able to track more than 4 lakh houses across 17 states at different, which are in different stages of development. For example, it could be a not started condition, it could be a foundation laid, it could be lentil level, roof level, and completed level. So the money spent versus the actual happenings on the ground can be tracked both from mobile applications as well as from satellite data, because the entire thing gets mapped onto satellite image based geoportal, and this geoportal helps us in understanding how the money is being spent for the Housing for All program. We have been able to use the satellite data for a very unique application, which is called as a Telangana Water Resources Information System, which helped the Telangana government to literally geotag 45,000 water bodies on the ground, and they were able to develop 23 major and 53 medium water related projects, so that the cropping pattern statistics can be utilized for better and improved cropping pattern analysis on the ground. And all the major medium irrigation as well as the monitoring and evaluation of the irrigation system could be accomplished with this kind of a program. You can see how an interactive mapping mechanism was built using online WebGIS tool, which helped Bone to be utilized even at the ground level to make very clear boundary conditions for addressing the entire irrigation system, which are basically based on the water storage capacity, as well as with respect to the kind of land use that comes up as part of the Telangana Water Resources Information System. So basically it is like usage of water for agricultural activity, the storage of water, the quantum of water that is available for irrigation or the agricultural activity, how much amount of water can be used, what kind of crops can be grown. All these things could be addressed because you have total information with respect to the water availability, with respect to the kind of command boundaries we have, and the kind of developmental activities that happens with respect to the crop growth. A typical example on how the browser has been used for such purposes. If you get into the ocean front, this has been one of the important applications from the space, which INCOI's Ministry of Earth Sciences has been using it, particularly in the coastal regions for potential fishing zone analysis, wherein the chlorophyll and the sea surface temperature information becomes very important for exactly understanding the location or the available of fish school, and we can give this information to the fishermen so that they can go to the right spot for fishing. The recent address, what we could do from our GPS constellation, that is Navik, was to see that we can give location based information so that the fishermen can use this particular data at the field level. They can go to the exact point through navigation system using our own mobile app, which works on the Navik, and they are able to exactly get to the point where the potential fishing zones are there. While they do so, they will also get the weather information, the sea state forecast, and it also is implemented in multilingual support. This is a typical disruptive technology that I would say was developed, which helped the fishermen in a very big way, particularly in Kerala and Tamil Nadu. It has been deployed and utilized by the fishermen in a big way. The advantages of this is that even while they are navigating deep in the ocean, they are connected to the system through our Navik, and this Navik helps them to navigate. At the same time, they are able to get the best fish catch. See, this is another unique application, again goes into the e-governance, where we use GPS and accelerometer that is available on the mobile to find out those roads that are having a lot of potholes. So you can see the color codes here. The good roads are shown in green, the moderate. For example, if a mobile application is fixed onto a vehicle and the vehicle drives across the roads, you will get a map at the end of the day wherein it tells you very clearly the condition of the road. Depending on the condition of the road, the government is able to take a decision on quick implementation of exactly those roads where it requires to be repaired or improved. This was done in Nasik, and a similar kind of a thing was done in Haryana, where the application was called as Harpat, where the entire government positioned itself to utilize this entire data, both from space as well as from the mobile. And the geospatial platform of Bhuvan was utilized as the primary WebGIS platform to see that real-time instant feedbacks are made available both to the users as well as to the PWD, so that accountability of road repair could be addressed straight away in using these kind of applications. While we address varieties of these kind of applications, which addresses very clearly the use of technology, we have also been able to use the geospatial technology, especially the multi-layer modeling with the information from the villagers, to see how well a village can be developed with respect to the watersheds. Particularly when we take GIS maps to the villages, obviously the maps cannot be understood so easily. So we have adopted a simple method of drawing a Rangoli map on the ground, which matches with the satellite data, as you see on the right hand side. And the villagers are able to interact with these kind of maps, and they're able to present their problems on the ground. And when you address them and implement the right kind of applications on the ground, you are able to see a drastic transformation. This is a before pre-treatment image on the left hand side. This is a post-treatment on the right hand side. You are able to see a lot of gully terrain we were able to afforest, as well as you can see here also. And in this particular area, you can see tremendous implementation of greening activity as well as towards this point. In fact, the beauty of the water conservation also can be seen that an increase in the inflow of the water could also make them go for excellent afforestation on the banks of the small waterfall. Coming to the rural applications, which is very important actually, because I'm taking an example of Bangalore, which is one of the fastest growing cities in the country or in the world. So when you look at Greater Bangalore, the way you see it, this is the metropolitan development. So this is the BBMP boundary as we see here, but this is the Greater Bangalore. There are a lot of issues with respect to the Bangalore and the growth of Bangalore. So what we have done is we have been able to map Bangalore over a period of time. This is the 1973 image of Bangalore, where you can see the beautiful drainage pattern of Bangalore. All the water bodies as well as the streams are pretty well mapped in this. But when you go into the multiple time frame of this, as you move from 73 and towards 2023, you literally see the haphazard urbanization that has taken place over a period of time. And in fact, Bangalore is overflowing its BBMP boundary. In fact, BBMP boundary, as you can see, is right here, but Bangalore has already overgrown that area. And the way the urbanization has taken place, there are a lot of chaotic conditions on the ground. And literally, you can see all the connectivities, what you see in 73 data slowly vanishes over a period of time, because a lot of encroachments have taken place in all these areas. And towards the 2023 images, you can see literally all of them are completely polluted. So there is a need, there is an urgent need to make a lot of improvements with respect to the current Bangalore as well as future Bangalore. So an activity has been taken up in this particular area, where 73 data and 20 data, when you compare, as you see on the right hand side, of course, the population growth has been something like from 1 million, we have gone to 14 million today. So there's a huge amount of population, and obviously that many number of vehicles are also onto the road. So every urban area will be facing a similar kind of a problem. It needs a proper planning and solution. This is a typical example of a very old 73 data and the kind of encroachment that has taken place. You are able to see very clearly. You can see in the previous image very clearly the stream network is able to see, and down the line 2023 you can see all of them are completely encroached. That means each water body is literally separated out almost with no connectivity. The Raja Kaluve, what we are talking about, is completely choked up. So you need to see to that we restore the Raja Kaluves. That is one of the things which is being talked about. And we have also been able to do a lot of quantitative analysis, wherein what kind of a land use has given way for this kind of an urbanization. A huge amount of agricultural area has given way for the urbanization. That can be seen pretty well here, even in this particular statistics. So it is when you really look at an urbanization and the way it has to go, we will see today kind of urbanization, what has happened. We see plenty of poor local governance going on, very weak usage in technologies, because people will be sticking to the old times. Inappropriate planning leading to haphazard development, critical infrastructure shortages will be there, and major deficiencies we are able to see with respect to electricity, water, and all that. In fact, the environmental deterioration is a major problem which we face in most of the cities today, and very poor living conditions. There are umpteen number of things which can cause these kind of problems. The only way in which we can improve this is by going for a new technology called as digital twins. If we can look at digital twins, it is possible for us to build that new mechanism, wherein we have a physical object, which is the real object. We can build a virtual object, which is a digital clone of the physical object, and we can build a connectivity between the physical and the virtual object. Now, the virtual object can be subjected to varieties of different types of treatment, so that the result of that could be used actually onto the physical object. So we are setting out to do this kind of an implementation, where we use wide varieties of layers of GIS, like 3D city models will be used, satellite imageries will be used, and many other important parameters will be integrated as a stack of data. And this particular data can be used for the digital twin model building and approaches. And the entire data can be subjected to varieties of landscape analysis, particularly the complex urban system, the way we live in, can be subjected to varieties of treatment on the digital domain. And once we do that, it is possible for us to address the real applications. Typical example of a 3D city model that would look like, for example, you can see the Kantirava Stadium here, you can see the UV city here, you can see the indoor stadium there. You can build a virtual 3D city model of the real model. For example, this is the Nandi Hills. The natural boundaries of natural features will remain the same. This is a typical example of a very high resolution image of Vidhan Sauda, but it is possible for us to build a 3D city model of the same, which tells us how we can navigate on such a system, which allows us to literally turn this into a 3D city model. For example, we are looking at the High Court building here right now. It is into the geospatial domain. It has been positioned onto the geospatial domain. It is possible for you to do all the necessary planning interactively on such a system, because these are images taken from ground as well as from space. You can see Vidhan Soda right in front of you. You can go to different parts of Vidhan Soda. You can get into the details of that. So this kind of an example helps us in understanding our systems better. In fact, this is a typical 3D city model, which we are able to use it from the open layers, and we are able to integrate the entire sensor system onto this. That means ground-based sensor systems can be implemented on a 3D city model, which gives us the complete information about possibly traffic. It could be the sewage, it could be the electricity, it could be varieties of other parameters which are required for a comfortable urban living. So once we are able to integrate this, literally all the various requirements of an urban dweller can be simulated and we can use it. So it helps us in better designing and operating and maintaining. It reduces the environmental impacts. It improves the resource utilization and possibly even economy. And varieties of advantages are there, as I have listed out here. So the best way to go for a city development today will be the digital twin implementation rather than going by the olden techniques of master plan preparation, etc. In fact, smart cities development can utilize these technologies. In fact, we have done this in Naya Raipur. As you can see, literally very high resolution images have been used for GIS applications here. And you can see a very high resolution image literally shows you all the details what you need. In fact, the kind of SCADA system that has been used for water supply, sewage, the traffic management and various others. In fact, the entire power display board integrates with the GIS data so that the entire city is literally in your hands for varieties of planning and developmental activities. This is another example of how do you address the air pollution in a particular city, particularly a place like Bangalore. It is possible for you to use varieties of sensor network. You can use the cloud-based techniques. You can use very simple sensors on the ground, and it is possible for you to build mobile applications, integrate them, and get the data. So when we try to do the modeling of the pollution in a city like Bangalore, particularly when we are addressing particulate matter 2.5 and particulate matter 10, we need to have satellite data which gives us the landscapes. We need to have the road information that gives us varieties of information with respect to the kind of vehicles flying on the roads. We get into the meteorological data because wind speed, wind direction, and rainfall all become very important, including the traffic density data sets and the type of vehicle and the amount of emission that takes place. All that gets integrated into a model which provides very unique data. For example, our model is able to make a very good prediction with respect to the April-May time where we have relatively less amount of pollution, even though you can see the pollution in the nice road area here. In fact, it is slightly more in 2019 as compared to 2016. I'm just comparing a 2016 versus 2019. We can do it near real time. But if you look at the November and February, the amount of pollution seems to be maximum. So depending on the different seasons and the pattern of the wind, the pattern of the various weather parameters, the pollution conditions keep changing in any given city. So this could be very well monitored, and machine learning models can be used for even making predictions. All these can be integrated onto a very good platform which ISRO has built. It is called as Bhuvan Geoportal. Bhuvan Geoportal has varieties of tools, thematic maps, open data, crowdsourcing mechanisms, visualization in 2D and 3D, mobile applications, wide varieties of satellite data. In fact, we have more than 40-50 terabytes of satellite data that sits on this, and it enables this particular platform works in varieties of mode where applications can be literally implemented. In fact, we have more than 40-50 applications running right now for the country. It sits on a very interesting infrastructure. We have an excellent cloud built in Hyderabad, and there is a distributed computing mechanism that has been built. All the satellite data, elevation data, and thematic maps reside on the system, and it gets served to the users in the real time. It has the operations like web map services as well as web feature services, and these are very important for the users, particularly today with respect to the space policy that has come in. It is possible for Bhuvan to provide the web map services and web feature services and web tile services, so that all the users can get the data online and utilize it on their own GIS systems for varieties of applications without any problem. And we look forward for these to be enabled already, because these are already available in the system. The beauty of the Bhuvan is it does excellent crowdsourcing, where people can contribute a lot of data to the system under different types of conditions. It could be field survey data, it could be during disaster damages, it could be watershed development, or even incident reporting. That way, this particular platform is a very agile platform which consumes and provide wide varieties of data. So before I close my talk, I would like to enthuse the audience here that it is time for ISRO and the user community to get into hyperspectral image processing, because that is one key area which needs to be developed in a big way, so that we can address wide varieties of applications in the country. Thank you very much.
Thank you, sir. I'm allowing everyone to unmute yourself and you can ask question directly. Okay, Venkat, go ahead.
I am Hegde. I have a small question after Venkat.
Okay, sir. Venkat, go ahead.
Okay, thank you, sir, for your talk. But unfortunately, I had some network issues today, so I joined a bit late. So I missed out some first 15 minutes. If you could please summarize and repeat after everyone are done, it would be great.
Venkat, you can watch in YouTube. We live streamed our program. So afterwards you can check out. Okay. Anything else?
Yeah, I've got just one question.
Hmm.
So, a few slides ago, I saw you were showing 3D models of multiple areas, multiple locations in Bangalore.
Yeah.
So, my question was that I have I've tried to do such 3D models, not exactly in Bhuvan. I've used such outsourced data to get say terrain relatives in 3D platforms like Blender. So how can we combine this into making say one animation to make sure that say we are having a digital twin of another city?
Yeah, basically you need to get a little bit of exposure to the geospatial technology which I was talking about. So anything you bring in should be geometrically all right, and it should be radiometrically corrected. And these kind of things are done these days when you download the satellite data from anywhere, and it is possible for you to bring that into a geospatial domain. And in the geospatial domain, there are a lot of tools that allows you to generate these kind of tools, and you will be able to integrate them for varieties of applications. This will need a little bit of training for you. You're quite young, and I really appreciate the kind of interest you have in this. But it's not difficult for you to pick up these things. It only needs a little bit of exposure and practice. Yeah.
Right, because it is much tougher to recreate, say, individual buildings rather than a more terrain relative.
Yeah, today the technology allows you to do that. We have good high resolution data. We can use drones for high resolution data capture. It is possible for you to integrate the drone data with the space data. Today space provides you something like 30 centimeter kind of an imaging capability. So you can prepare your base at 30 centimeter and you can use drone data also. Yeah.
Right, and people themselves can contribute as well.
Absolutely.
Yes.
You're right. You're right.
Thank you, sir.
Thank you. Thank you.
Professor
Good
Divakar,
afternoon, Venkat.
Divakar, sorry, can I pitch in for 1 minute?
Yes, please.
Excellent talk as usual. Excellent talk as usual. I missed the initial part. Anyways, I have a small question because, long ago, you predominantly, you and all of us talked about, OpenGIS, Vector GIS, Raster GIS. From that day, we have come today to integrating GIS database uh, with cloud computing possibilities.
Yeah.
So basically, with respect to integrating cloud with the GIS databases in India, where do we stand? Because are we today open enough to solicit larger participation of geeks into using the complete power of internet and cloud resources for GIS-based services, or we still hold that monopoly databases like Bhuvan, WRIS, NDEM, NRD, or NDE, what is that, our meteorology database. So
Yeah.
are we still into silos, isolated kind of environment? Are we totally open? If so, what are the security issues? I mean, question is long. I will discuss with you separately, but briefly you can highlight, because today that is a buzzword, integrating GIS databases with the cloud so that various kinds of analysis, including the digital twin you're talking and beyond, is possible.
I think it's a very good question, very relevant question for today, because that's what I was addressing at the end, that today the geospatial policy has been relaxed and it has been enabled for us to really get into a private cloud. In fact, this entire Bhuvan can basically become a private cloud for people to consume WMS, WFS, WTS services. All the data that we have on Bhuvan can be enabled for serving the entire country. But it has not yet happened. As you rightly said, it has not yet happened. But WMS services have already started in Bhuvan, and I am sure, in fact, I have written to them also, requesting them to convert this into a cloud so that it can be used by every platform in the country for varieties of development. Because a lot of value-added products can be developed using the kind of data what we have already on Bhuvan. As you rightly said, if you don't enable those services on Bhuvan, Bhuvan will remain to be the same old as it was some 5 years back. So we need to change that. For that, they have to enable the services, because nothing can stop. Today, we have the policy that enables you to allow this kind of a data to be made available for everybody to utilize. So far, all these databases, what has been created, still remains in the respective forums. But obviously, Bhuvan is one integrated forum which we developed, and today Bhuvan is a cloud also. So it is possible for us to convert that into a private cloud and enable all these services. It's a very simple thing to be done, so that the entire country utilizes this particular data on their own platforms for varieties of research. In fact, it will streamline that kind of a research which possibly has not been seen earlier, and a lot of youngsters will be able to contribute in a big way.
Sir, Srinath here. I have one information and two questions to you.
Thank you so much. Yeah.
Thank you, sir.
Precisely answered. Thank you so much.
Sir, Srinath here. I have one information and two questions to you. One information is regarding the boy who has asked a question. He is a young space scientist who has published a paper in many of the space conferences and enthusiastic space scientists. Question number one is, we have Dishank with respect to the state government Karnataka, where the agriculture assets have been very well available. Do we have similar app or system across other states in India? That is my first question. And what was the contribution of our Bhuvan or our ISRO? I know that these maps are all used best. Just on general, your view. Second question is about
yeah.
I think I'll get back to you, sir. Second question.
I'm not able to hear you.
Yeah, you can answer first question, sir. I'll get back to you.
Okay, it's so nice to know that the young scientist, the first one who spoke to me was an young scientist, and he has published papers. I'm really very happy. I would be very happy to interact with him more and more and help in whatever best way I can. Such are the young scientists we need in the country today. As far as Dishank is concerned, yes, I have seen that particular app. It basically provides the information at cadastral level. That means it basically provides cadastral boundaries for anybody, and that could be used for varieties of other information. Basically, it is cadastral data that it provides. Bhuvan does have cadastral data in many states. Wherever the states have shared the the cadastral boundary. For example, you go to Telangana or Andhra Pradesh, they have been able to share the cadastral boundary, and we have been able to superimpose cadastral data with land resources data. That is a very unique thing. And as and when we have time series of the time series data of satellite data with respect to different cadastres, you will be able to monitor what really is happening to our natural resources on the ground with respect to different farmers taking what kind of agricultural activities that is possible. So Bhuvan in fact has a lot of cadastral data similar to Dishan, but it is at a much larger scale than compared to Dishant. Dishant is available for Karnataka and it provides cadastral data. I have used it, I know what it is. Yeah.
Yeah, thank you, sir.
Thank you.
Any more comments or questions?
Can I
Sir, good afternoon, sir. Srinivasan here. Sir,
Okay.
it's a wonderful lecture. Only thing is the publicity for Bhuvan is not much. So people straight away go to Google Earth or any other foreign tool. So this publicity for Bhuvan is very much required. As Srinath told, Disha Katha is very useful. The other states also should adapt, and enough publicity should be given for people to see that this tool is available and they can make use of this.
I fully agree with you. In fact, a lot of efforts have been put by ISRO, Department of Space, by pushing on Bhuvan in a big way. Even myself had gone into n number of workshops where we have propagated in a big way. But we need to sort of propagate that through utilities and examples of activities that can be used by a common man. More and more of that kind need to be done, and possibly like those people who would have listened to me today could utilize Bhuvan for certain applications and uplink it onto the YouTube or put it in social media so that it becomes popular. I think that is another way of doing it. More and more addressing of Bhuvan and its advantages in the social media will bring it up in a big way.
Yes, sir. Thank you.
Thank you very much.
Can I interject?
Yeah, Venkat. Yeah.
Okay, so how do you think that using Bhuvan as one anchor, we can create multiple apps to do as much smaller purposes? Like for example, if we check, GPS is one very big system, and in that we have much smaller applications like Google Maps, and I've used USGS multiple times, etc.
Already Bhuvan is providing a lot of information and a lot of utilities for people. For example, there is one very interesting application which has been developed. The entire country's post offices, all the post offices in the country has been geotagged and put. So, for example, if from your house you would like to do some important work with respect to post offices, particularly the old people would have more things to do with the post office. So they will be able to understand what kind of facility a particular post office provides and what kind of utilities they can use it for, how to reach that particular post office. Just like Google would do, same thing you can do it on Google also. So we have 1.55 lakh post offices in the country. That is the beauty. And this is just one example off the hat I'm telling you, but there are many other interesting applications that can be utilized. For example, I'm just working with a team which is looking for improving the water conditions in the northern part of Karnataka. So what is the best way we can improve the water resources in this region? So we are looking at soil, we are looking at putting the farm ponds in the right places so that the drainage system, for example, DEM, the digital elevation model, tells you how the water will drain in a particular area. Where should I put the farm pond so that the water will collect and it will percolate into the ground so that the groundwater gets replenished. So actually the Bhuvan serves a common man with respect to natural resources management in a much bigger way, and we wouldn't like to do what Google does. There's no point in repeating something which has been done. We are doing much differently with respect to natural resources development and helping the people in a big way. For example, entire country's groundwater resources information is available. So I would like to know, where can I go for a borewell? You will be able to use Bhuvan for it. That kind of services we are providing, which is pretty unique, and every countryman should know that Bhuvan provides that kind of services. That's why I'm saying if we popularize this on the social platforms, social media, maybe it will become more and more usable by more people. In fact, everybody can use it, and it has vernacular languages. 5, 6, 8 languages have already been integrated, so people can use from that. The Tamilians can use, Telugu people can use, Maharashtra can use, Orissa can use, and many others. Yeah.
Yeah,
Sir, just one more question, sir, regarding this using natural resources for renewable energy sources.
Just a minute, Srinivasan sir. I think Venkat was about to say something. Let him complete, then I can come to you.
okay, thank you, sir. I completely agree with what you said. I just wanted to add that the way I've seen or observed Bhuvan, it's much more web-based and much more web-focused compared to, say, the current India, which is growing a lot more on mobile phones and apps. And it's there are multiple apps, but I think it has to be more frequent and generalized. Thank you, sir.
Thank you. Actually, we have mobile Bhuvan also for your information. So you can have it on your mobile. It's a less heavy one, which easily works on your mobile also.
Okay.
Yeah.
Thank you, sir.
Thank you very much.
Sir, I will just continue regarding this using these natural resources. So it will be useful whether information like where all this we can use the solar power, how much sunlight is there, different months, wind power, tidal power, those things, so that more and more people will be install these things and use the natural resources.
Yeah, that's a very interesting information. Today we are able to use the INSAT, the information available from INSAT system. We are able to use the solar insolation from INSAT to find out how much amount of solar power can be exploited from a rooftop. And we have a solar calculator, a mobile app, which has been created, which can be utilized for understanding if you take a full annual cycle of the sun availability, how much amount of power can be generated on my rooftop can be estimated also. But the whole thing works on a different site in ISRO. The same thing can be integrated onto Bhuvan also. That is not a problem. But it is a very interesting application which already ISRO has developed it. And in fact, Honorable Prime Minister popularized it even when he was in UN recently, wherein he said that these kind of applications can be utilized for entire Africa also.
Yeah, it helps in that zero carbon thing. But
Yeah,
thing is, the awareness is not there. That's the issue.
Yeah, that's right. That's right. I think we need to do more of awareness building now. Get into more social media and popularize it, or go into Insta and give more information about such kind of things. What can be done?
People think still a lot of government control is there, and they don't have access to this thing. So that misconception is there that needs to be removed.
Yeah, now actually things are much relaxed. We don't have any government control due to the recent reforms in the recent times. So things are much different, and the department can take initiatives to popularize these things on varieties of platforms, and it can be used.
In fact, in TV and FM also can be used to tell. So people will be driving, and they will be, I mean, another mode of publicity. Yeah, thank you, sir.
Yeah, thank you. Yeah, somebody else.
We are also popularizing active forum about our Bhuvan. NRSC colleagues have given talks in our forum. Hakim, Arul Raj, Mahalakshmi, all people have given, many people. But in BSc students, we are asking them to access the Bhuvan portal and do small projects to submit as a part of their BSc completion, which Supriya is right now working on that to give student project in BSc. Actually, it is now more popular, sir. In fact, we have that perception that many people do not know Bhuvan, but already people have started using student. Many people, they are coming with questions and some complaints. That's okay. We can look at it. Otherwise, Map My India here, which is also one of the ISRO effort. Of course, it's a private internship, but it is still being used by many people. People can look at it.
Yeah, you are right. I agree with you.
Hello.
Good afternoon, sir.
Yeah, please.
So actually, we are from.
Sir, just now we completed our graduation in geoinformatics and computer science in Gadag RDPR University, sir.
Just a minute. Somebody was speaking and suddenly.
So both are same.
Yeah, sir.
Yes, sir.
We both are using the same.
Both are together.
Okay, you cannot speak together. Okay, one of you speak. Okay, go ahead. Go ahead.
Sir, actually, we have completed our graduation just now, sir,
Okay,
in geoinformatics and computer science.
yeah.
So, as you told that you give the one of the group for
Your voice is going off. I'm
Karnataka.
not able to make out what you're saying.
Sir, actually, you were looking for a group, sir, for a North Karnataka water facility, right?
Yeah, we are doing it. Yeah.
Sir, can we contribute for that, sir?
Can we be a part of that, sir?
Yeah, sure. You can get in touch with me. You can take my mobile mail address or something. I think Supriya will provide to you, and you can get in touch with me. We'll see how well you can integrate with us on this.
Sir, how can I get? How can we get? Contact you. Sir.
Just now I posted my WhatsApp group link in chat box. You go there and click on it. You will join our WhatsApp group, Creative Team. There, admin, anybody you over there, they will help you to connect with us. Okay.
Ma'am, we are unable to see that any link here, ma'am, in chat box.
Okay, I'll text my number also.
Ma'am,
okay, test your mobile number.
Chat. You can see it on the chat.
No, sir, it is not visible.
Once again,
I have to. Actually, Divakar is a busy person. I think your group should get in touch with him when you need specific advice.
Okay.
You see, if you expect him to react to anything and everything you do in your group, which suppose for some reason he's not able to do, you say that he didn't participate. The best is you pose your specific problems to Divakar and seek his guidance. Okay. I have been one of his colleagues. I know the various other commitments he has got.
Okay, sir. I texted private message also. Please check it out. Okay, Ashok sir.
Ma'am, if you don't mind, I have some doubts, ma'am.
Okay, you can ask.
But it is not a part of like the session. It is not a part of our session.
Yes, you can contact me. I'll connect with sir. Okay.
Ma'am, but still it is related to our JS, ma'am.
No, we will talk separately on that. Don't worry, I'm available to you. We can talk on telephone.
Okay, Dr. Ashok
Sure,
sir.
sir. Thank you, sir. Thank you so much.
Yeah, thank you. No problem.
Sir, I am having one question. During drought conditions, how do you utilize the sources and make it a good or a normal going presentation in ICT?
I could not get you. Can you repeat your question?
Sir, how well you can utilize and do the resources during a drought condition in ICT?
During what? What condition?
Drought conditions.
Drought conditions.
Drought conditions.
Talking about drought. Okay.
Sir. How well you can use and the work only stops to some ongoing to some extent, or you can proceed as in a normal pattern. See,
drought is one particular thing which can be very effectively handled using space data. We have established an operational center in Delhi which addresses the onset of drought much in advance, because we use time series satellite data and we are able to exactly predict the possibility of having drought in a given time. And it is so well done over a period of time. In fact, National Remote Sensing Center established a methodology long time back, and it has been operationally used today. So we utilize various indices and parameters from satellite data, particularly the vegetation index, continuous utilization of vegetation index, and weather data. Integrating many other information allows us to understand, for example, soil moisture conditions. We are able to integrate into a GIS domain, and we are able to exactly say this particular year, this particular area, spatially we are able to get the drought, or when it is going to be the onset of drought. Some of these things can be pretty well established or estimated. So drought prediction is an operational tool today, and in fact we have transferred this technology even to Sri Lanka, wherein they wanted a similar kind of a thing. Under the UN Charter, we were able to do this, and even that country utilizes our tools and our technologies. So your question was something related to drought or much beyond that?
That's what mine. And how do you utilize the resources From where do they come and how?
Divakar, I want to make a small suggestion. A couple of days ago, Department of Science and Technology has asked for proposals for developing various solutions. They want the proposal to come from an academia-led consortium, academia, SME, then somebody else, and the user.
Correct.
Especially this group working in Gadag or whatever, they can go through. What I will do is, end of this session, I will share that link with Divakar if he already does not have it. I am sure 99% he has it.
I've
I'll
seen
still
it, yeah.
share with him. See, there are plenty of opportunities, and DST is offering funds also.
Correct.
So get into one of those projects, and I am sure on behalf of Divakar, I can tell you, he will be more than happy to guide such teams and seek only guidance from him. Okay, so the effort has to come from the interest groups. I will do that. I will share the link end of this talk with Divakar. He can put it on the larger group.
Thanks a lot, sir. That's a very good point which you made. Yes, very much. It's very useful.
Okay. Any more
Supriya.
questions? Yes, sir.
Supriya, suggestion is through Divakar sir, you also catch hold of Hegde sir. He should also address sometime.
Yes, sir. Sure, sir.
Hegde sir, hope you have heard my request.
Okay.
Okay. I think we can conclude, sir.
Yeah. Okay. If there is anything more further, we can conclude. Yeah.
Yes, sir. Sir, if possible, you can mention your email ID so that if anything, they can discuss with you.
Okay. My email ID. I will just tell just like that. If you can note down slowly, I will tell. DIWAKAR Divakar. DIWAKAR @NIAS. NIAS stands for National Institute of Advanced Studies. NIAS .RS .IN. RES, sorry. NIAS .RES .IN. Is that okay?
Yes, sir. Okay. Okay. We can conclude, sir. Okay. Sir, we extend our thanks to you for accepting our invitation and sharing your knowledge and inspiring us towards this concept. Thank you very much, sir. Thank you one and all for joining with us and for being with us. Thank you, sir.
for the
Thank you.
presentation.
Thank you all very much.